Hi, welcome to week 4 of Drug Society Behavior. This week it's the lecture from the downhill ski hill. All right. The topic this week is the bio part of the biopsychosocial perspective. We're going to get a deep dive into the biological functions of the human body and how drugs affect it. So, with no further ado, let's get started. All right, getting off the ski lift now, and this is my brother Dave here.
Hey, don't take any pictures of me falling down.
I'm going to include all the pictures of him falling down in our lesson today. Here's the first one, coming right up here. All right, so for this lesson on the biology of drugs, I'm going to start by talking about the general area or areas in which drugs affect us, and that is, of course, the nervous system. So the human nervous system is made up of two parts. The central nervous system, which includes the brain stem, and areas of connected to the brain near the head, and the peripheral nervous system, which are all the nerves outside of your head, down your spine, and throughout your body, innervating your muscles, your sensory organs, and digestion and things like that. So, what is a nerve? A nerve is a neuron. Neuron's a cell that is very small. You can't see it with the naked eye. It's made up of essentially 4 parts. The main cell body, in which there's a nucleus, which helps provide the energy for the cell. There is the dendrites, which I like to refer to as arms. The arms of the neuron. There's the axon, the long extended leg of the neuron. And there is a myelin sheath, or a fatty deposit around that axon, for reasons I'll describe shortly. Aside from that, inside the cell body, I think I mentioned the nucleus, that's the 4th part. Neurons make up the central nervous system, as well as the peripheral nervous system. The neurons in the peripheral nervous system can be quite long, whereas the central nervous system, brain neurons, are generally quite small. There are approximately 90 to 100 billion neurons in your brain. Pretty fantastic. And those neurons are all responsible for the activity that goes on in the brain, which ultimately turns into consciousness, how we experience the world outside of our bodies. So, there are other cells in the brain as well that help to feed and provide energy and nutrients for the neurons and clean out some of the waste that the neurons produce, and those are called glial cells, G-L-I-A-L, glial cells. All right, so that's those are the structures that make up the neurons, the brain rather, the central nervous system and the peripheral nervous system. And they connect together into vast networks which describe the different parts of the brain, all located in 4 different lobes of the brain. The occipital in the rear, the temporal, the frontal, and I'm going to have to chime into that 4th one. All right. All right, so there are 4 lobes of the brain, and there are other areas certainly that are important. You'll see reference in the textbook to the nucleus accumbens, the limbic system, the amygdala, other areas that are directly related to brain function, which, of course, again, produces consciousness and how we feel, how we think, how we act. That's all going on in the brain. And the peripheral nervous system, let me talk about that for a moment. The peripheral nervous system, all the nerves outside of the brain that go into your organs, muscles, etc., arms and legs, that's broken down into two parts. There are certain things, aspects of the peripheral system that you don't really have much control over, like how fast your heart beats. Of course, you can go running and increase the speed, but that's not you doing it consciously. That's the body reacting to the need for more oxygen. But that's a automatic function of the brain. There's other functions like blinking, nothing that you think about usually, but you need those eyes regularly cleared out, so your body kind of takes that function over from your consciousness. All those involuntary, unconscious actions of your body that are controlled through the nervous system are part of the autonomic branch of the peripheral nervous system. Autonomic. I like to think of it as automatic because you don't have to think about it. The other part, where you raise your hand to ask a question in class, or you go reach for your drink, or want to go for a run and you want to control your body in a particular way, the muscles of your body reacting to mental stimuli, your thinking, your consciousness, that is all part of what is called the somatic nervous system. Somatic, S-O-M-A-T-I-C. Somatic comes from the word soma, an Indian word meaning body. So that's the peripheral nervous system, and it's two parts, autonomic and somatic. One last thing about the autonomic nervous system, it can act to often change the tempo of your body, let's say, increase heart rate, increase blinking, increase the width of your veins and arteries so that you get more blood flow into the extremities of your body, increase the dilation of the pupils so you get more light into the eye and can see things better. That all of those functions are related to what we call the fight or flight response of the autonomic nervous system, and shutting those systems down, we'll call it rest and digest, to help us remember it's shutting things down. Rest or digest is the shrinking of the blood vessels, the decreasing dilation of the pupil, slow heart rate, and so forth. So the autonomic nervous system, other than just keeping a homeostasis or balance, can increase functions or decrease functions depending on circumstances. Let's move on now with the central nervous system. What's going on in the brain and these neurons, 90 billion of them that make up the brain. Alright, so on with the central nervous system. The central nervous system, brain and associated parts, is controlled essentially through a complex system of networking. The network of the neurons is created by an attachment of the dendrites, or arms of the neurons, to the axons, the legs of the neurons. The axons and dendrites connect at a certain particular point where, well, there isn't exactly a direct connection. There's a small gap between the two parts, and that is called the synapse. And something remarkable and magical happens in that synapse between every connected neuron. Those neurons are connected through a system of chemical and electrical impulses known as neurotransmission. Transmission of messages between neurons, neurotransmission. So neurotransmission happens with different chemicals. Many of them you may have recognized the names, may have heard the names before. Serotonin, dopamine is probably the most common one I talked about. Norepinephrine is one that's released in relationship to the hormone adrenaline. We've got a number of others. GABA, glutamate, endorphins are a natural neurotransmitter that mimics or is mimicked by the drug opium. And all of these neurotransmitters are essentially responsible for, again, how we think, feel, act, consciousness, our muscular movement, involuntary movements, and so forth throughout the nervous system. Now, let me give you a rundown of the life of a neurotransmitter. What is the life cycle of a neurotransmitter? It starts out as just parts. These parts are called precursors. Precursors make up neurotransmitters, and they have to be arranged in the proper order in order to do that. The process by which the precursors are turned into neurotransmitters is called uptake and then synthesis. So the cell takes the precursors into the right enzymes, and the enzymes synthesize those neurotransmitters. Uptake U and synthesis S. The next S has to do with what it does with those neurotransmitters. It stores them in little packages called vesicles. The vesicles store the neurotransmitters. Okay, I'll get on to the last three parts of the life of the neurotransmitter. Thank you.
Wow. My elbow.
Right, the elbow. This is a smaller lift.
What?
This is a smaller lift.
Yeah, very cozy.
All right, so the second half of the life of the neurotransmitter. They've been stored in the vesicles. After they're stored in the vesicles, this is gonna be the sock puppet version of the lecture today. After they're stored in the vesicles, the neurotransmitters then need to be delivered through that synapse, that connection between the dendrites and the axons of two neurons. And that happens when an electrical signal comes down the axon. Now remember that fatty sheath or covering I told you about on the axon? That's necessary to protect the electrical signals that happen within the neurons of our brain. Just like an electrical cord that you see hanging off of the telephone wires, or a cable that you have coming in for your internet, it's all covered in this plastic or rubber, right? And that's to make sure that the electrical charge doesn't veer off of its path. So the cell builds these coverings for the axons so that when an electrical signal comes down and signals the neurotransmitter to be released into the synapse, it'll get there. All right, so that's what we call the action potential. That electrical signal is known as the action potential. It involves polarization and depolarization of the cell in these micro levels of electrical activity that happens in every neuron. I'm not too concerned that you understand the electrical aspects of that polarization cycle, but just recognize that it does go through the cells go through a cycle of electrical activity which send an impulse to the end of the axon, which essentially tells the cell to release its neurotransmitters to the next cell, into the synapse, and the dendrites of the next neuron pick up on that release as they bind into these kind of lock and key mechanisms that exist. If there's no lock and key between two cells, they won't react to one another. But if they do bind, the neurotransmitters bind to the following cell, then that could trigger another action potential in that cell, thus activating a network of cells within the brain that allow us to create certain functions, experience certain feelings, allow us to move our bodies, and so forth. So, the neurotransmitters that we know about number of over 100, so we can't go into all of the neurotransmitters, but I do want you to learn 7 of them. And I'll give you an acronym to help remember them. The acronym is SNAGGED, S-N-A-G-G-E-D. And SNAGGED stands for serotonin, norepinephrine, acetylcholine, GABA, glutamate, endorphins, and the big one, dopamine. All right, so in the next section here, I'll just talk a little bit about the functions of each of these neurotransmitters, what they do for us, what they do to us, and how they affect things like mood, feelings, activity, and so forth. All right. Where's my sock?
I got tired. My hand got tired, man.
My hand got tired, man.
I need some more dopamine.
Dopamine. They're going to love it. Okay, so what are the neurotransmitters all about? All right, so serotonin, very much related to the symptoms of depression, maybe related to aspects of visual acuity and how we see the world. For instance, hallucinations could be triggered by differing serotonin levels. Many other functions that serotonin involves. Norepinephrine gets you going. That's, again, the neurotransmitter that's related to adrenaline, and that will activate many systems, particularly the autonomic fight or flight response. Acetylcholine is one that's related to muscular function. Neurotransmitter for muscular function is very important, obviously. That's a neurotransmitter that, when affected, could, when affected negatively, when you don't have enough of it, it could make you shaky, could have other aspects of neuromuscular issues related to it. Many systems might be called cholinergic or anticholinergic. If you hear that term, it's related to acetylcholine. The choline in cholinergic is related to that neurotransmitter. All right, GABA, a general neurotransmitter that exists throughout the brain and is responsible largely for inhibition or slowing of brain functions. Glutamate is the opposite, another neurotransmitter throughout the brain, but is more associated with higher increased functioning. Endorphins, as I mentioned earlier, are natural function of the brain. Natural function of the brain to produce good, happy feelings. Produce when we do exercise. I'm producing endorphins right now. And dopamine, as you may know, is often related to the reward systems of the brain. Dopamine is released when we have happy, positive feelings, and that is very much related to those feelings of euphoria or general happiness when we do drugs. Okay, so drugs affect the levels of these neurotransmitters in ways that other chemicals or foods don't. That is why drugs are drugs. They alter the neurotransmission in our brain, and that's why we feel euphoric or feel sleepy or feel high or excited or stimulated or depressed or in any way different. Drugs are very much responsible for creating those differences. All right, moving on with the next section. Okay. Last thing I want to mention is how drugs can work as antagonists and agonists for neurotransmission. When drugs interact with the brain and the body in ways that produce differing non-homeostatic, you could call it, differing levels of neurotransmitters, and then of course we have the conscious experience of doing the drug as a result of that change in neurotransmission, that might be a result of a drug taking over, if you will, for a neurotransmitter. Nicotine, for instance, has a very similar chemical formula to acetylcholine. When we take lots of nicotine in, our bodies tend to reduce the amount of acetylcholine to maintain the homeostasis of that chemical. And eventually, if we continue as a habit to take in the nicotine, acetylcholine will stop being produced in levels necessary to maintain normal muscular function. So that doesn't feel good, first of all, so we tend to continue to take the nicotine in when we start getting that feeling of being jittery or nervous or tense or anxious as a result of not getting the dose of nicotine that we're used to getting, and therefore not allowing our body to produce the effects that it would have produced if the acetylcholine were there, but it's not anymore because your body has stopped producing it because you've taken the nicotine in. So that explains some of the feelings of withdrawal that can exist when a drug is removed immediately from the body, and then your body takes some time to rebuild its reserve of acetylcholine, and during that time the withdrawal symptoms can be pretty intense. So that's a case where the drug has acted as an agonist of a natural chemical, a neurotransmitter in the body. Nicotine is an agonist for acetylcholine. Opium is an agonist for endorphins. The euphoria of the opium high is exactly what you get when you get lots of endorphins running through your body. Ask a professional athlete how they feel after a really, really intense session of exercise or competition, and they'll tell you that it doesn't necessarily feel bad. Their muscles might be sore, but at the end, it's kind of almost a euphoric feeling after having built up a lot of endorphins to help mask the pain that can exist with intense exercise. That's the whole purpose of endorphins, is to keep you going in the event that you need to. Evolutionarily, it makes sense. Antagonists are those drugs that keep a neurotransmitter from being produced. For example, cocaine, I believe, is an antagonist of dopamine. And no, I beg your pardon. That's not right. I'm going to have to swipe this. Okay, click. An antagonist is the opposite. It's a drug that keeps or a neurotransmission from happening by blocking the receptors for particular neurotransmitters. So all of this explanation of neurotransmission in the brain leads us to suspect that a lot of the feelings we have in our lives are related to neurotransmission and the level of those chemicals in our brains and bodies. So drugs have been created specifically to alter those levels. For example, a serotonin inhibitor is a drug that keeps serotonin from being produced or possibly blocks the receptors. An antagonist of serotonin would do that. And if you don't have as much serotonin flowing through your body, the suspicion, the hypothesis, is that that will help decrease feelings of depression, feelings of sadness, and that will allow us to feel better and the drug would be responsible for that. So these are what we call serotonin reuptake inhibitors, when they don't allow the reuptake of the serotonin molecules. This up. Okay, hold on. There we go. And so that's what we call the monoamine theory of mood. That mood is produced by levels of chemicals in our body, and if we can change those levels of chemicals with drugs, the levels of neurotransmitters, then we will change our mood and resolve issues of depression and mood-related disorders. All right, so that pretty much brings us to a conclusion of Chapter 4 on neurotransmission. I will go on in the next part of the video to talk a little bit about High Price, Chapter 5, Rap and Rewards. Okay, Rap and Rewards, Chapter 5 in High Price is about, first, Carl Hart's enjoyment and love of music. And that love of music is a great thing that I share with him. Hopefully you can get some ideas maybe for the music blog out of this chapter. That's the latest assignment coming up at the end of the week. I believe that was last week, actually. So, but we'll be doing more of those. So take these ideas into the next assignment. We'll do the glades here. I got to pay attention. Here we go. So, Rap and Rewards is about his use of rap to validate a lot of how he lives his life and how he feels about the kind of desperate circumstances in some cases, how he deals with those desperate circumstances of the kind of life of poverty and discrimination and so forth that pervaded his youth. And he goes to these high school gyms and dances and starts hooking up with people who are doing the very first experiments with hip-hop and rap. He hosts events with groups that have now become famous, like Run DMC, Grandmaster Flash, Sugarloaf Gang. These are some of the earliest black artists who were getting into the scene of rap and hip-hop back in the 80s. So a pretty significant influence on him, as I think you can tell from his pride that he writes about those incidences with. And so that brings him to talk about the important psychological aspect of reinforcement again. Reinforcement for him was incredibly positive when he was able to kind of prove himself on the dance floor, if you will, as a up-and-coming artist spinning tunes. I think he called himself the Bionic DJ. And so that kind of positive feedback can really push people into behavior that they will continue doing. The positive feedback loops that can exist are strong influences in our life. We should pay close attention to them. There were also negative feedbacks, however, in this reinforcement cycles that happen. And at the end of the chapter, he discusses how the music scene was also infused with violence. And that violence, drugs and guns and music kind of going hand in hand, as he describes it, led to his sister being shot. His sister Joyce gets shot in the face. She comes out of it none the worse, other than not being able to get shots of pellets of buckshot stuck in her tongue. Sounded pretty awful. And he also describes how the negative reinforcement from his parents in his lack of support, and from her later in life, from his perceived lack of support for her after that incident, was fairly telling and profound. So these influences of positive and negative reinforcement applied to drugs include the euphoria and the high and the new feeling and sense of consciousness that comes with doing a drug, and why people go back to it and eventually may become dependent upon that drug. And the negative reinforcement is really very much about the withdrawal and what happens when drugs start replacing our neurotransmitters, and we get essentially hooked on them in a way that we may not want to, because they are in fact replacing the neurotransmitters in our system that we may not be so familiar with in a biological way, but we certainly can feel in a physical and conscious way as a result of the drug experience, the non-drug experience, in that case, of withdrawal. I'm wondering if I'm on the right slope here. I don't see anybody on the slope. All right, well, that wraps it up for this week. Thanks very much. We'll catch you next week with Chapter 5, another chapter about biology and drugs, but it's about the action of drugs. Okay, take care. See you on the flip side. Hi, folks. Just catching up with you here on assignments for the final part of the video. As usual, we have the chapter quiz due on Thursday, the online media due on Sunday, and then a discussion about neurodivergence due on Sunday as well. And I'm going to ask you to do a bi-weekly journal. This is the second week, so bi-weekly journal on chapters 3 through 5 of High Price. Thanks, I'll see you online. Oh, and if you're in the SOCI 370 section, you know who you are, I hope. I'll clarify that soon as well. Keep an eye out for an announcement for giving me a PIN number for a grades page. That's for everybody. But for SOCI 370, if you've turned in your concept paper, I'll be getting feedback to you on that very shortly so you can move on with the research project. Thanks. Everybody have a great week. Bye.